sine squared theta d theta dv. All right?
There's a
Yeah, there is a
There's a
sine
sine phi.
Yeah, there is a sine phi.
It somehow got written outside the thing, so I think that's.
Sine phi d theta dv. All right. So who can tell me the z component? T dot dA of y. Okay, so that's gonna be also 0 for the other components, but for a different reason. Because here we don't have sine phi or cos phi, right? But we are integrating with respect to phi, but each component here, let me go back here, the elements, so xy, so for the z component, what we need to look at is this one with this, right? So you have tzx with dx, tzy with day, tzz with dad. So when you multiply that with these three, and so you have cosine of phi from here, and tzx is this one. All right. So cosine of phi d phi integrated from 0 to 2 pi should be 0, right? So you multiply this one, e the x or txd, e the x with that. Means you multiply this with that, so you have cos phi d phi. All right? Yeah, d phi. So where cos phi d phi from 0 to 2 pi is going to be 0. So the x component is going to be 0. So what you will end up with for the z component is just only from 0 to pi over 2, from 0 to 2 pi of tzz r squared of this one. Sine of theta, cosine of theta, d theta, d phi. All right?
sine squared there. I mean, it doesn't matter.
Sine squared.
Oh, we're talking about the z term. I'm
Yeah,
sorry.
the z term.
Sorry.
So are you convinced that the other components are going to be 0? All right? Yeah, there is going to be one homework problem on this, so you should understand it. So what you would end up then is going to be, just to make it short, okay, now let's show also the x and y components. So this is the z component, and that is the y component, and this one is the x component. All right. So you can go through the algebra, and you can show that when you do the integration over the entire surface and look at the entire term for the force, which is going to be written as so what you would end up for the force is going to be F is going to be the x component, which is given by that. So that's going to be the integral from 0 to pi over 2, from 0 to 2 pi. Txx is just epsilon Ex squared and minus what? Minus half E squared times r squared sine of theta cosine of phi d theta d phi. That's along x hat direction. And what's going to be the y component? So that's going to be plus the integral from 0 to pi over 2, from 0 to 2 pi epsilon naught, and Tyy according to the result that we have in here, we can write it as E y squared minus half of E squared. The y component is given, has to be integrated over that. So that's going to be r squared sine squared of theta sine of phi d theta d phi. So that's along the y direction. And the z direction, that's going to be plus the integral from 0 to pi over 2, from 0 to 2 pi. And Tzz, we can express it as epsilon naught of Ez squared minus half of E squared of the area. That's going to be r squared sine of theta cosine of theta d phi. So now, what would you expect just from from a physical interpretation and from what we learned in ANM1? You should expect for the x and y components to cancel out, right? So you can show that just if I go back for Ex, I think we can probably easily show. If we go back and look at Exx. But at least you can look at for E squared, for example. E squared, it depends only on the magnitude of the electric field, right? So it's independent of theta and phi, right? So when integrated with respect to phi for this term, what would you expect? It's going to be 0, right? Because E squared is equals to q over 4 pi epsilon naught 1 over r squared, the whole square, right? So when you substitute that one in here and integrate with respect to phi, you can see that this one at least is going to be 0, right? For Ex squared, you can go back and look at what we wrote, and I'm sure it has some sine squared theta or cos squared theta. So when you do the integration.